All right, guys, so we're here today to talk about multi-compute governance. So my name is Zeashan. I'm a product manager. I work on catalog governance and security products here at Databricks. I've been an engineer and architect for way longer than I look. And I've got about 6 years of experience actually building things on top of Databricks over time with Spark, which is pretty cool. I've also been building scalable platforms and businesses for about 10 years.
And hey everybody, Zach Friedman. Pleasure to be here. Thanks for joining us. I'm Director of Product at Immuta. So I look after the product team that builds Immuta Secure. We offer customers a universal security and access control platform that applies across a variety of cloud-native data warehouses, lakehouses, data lakes. I'm originally a software and data engineer turned product guy. And then just briefly for that way.
Yeah.
Just briefly for some context on Immuta for those of you who are not familiar, Immuta is like I mentioned, we have security and access control product called Immuta Secure, but as part of the data security platform, we also offer discovery, does sensitive data discovery and classification, as well as detection, so it's user and data activity monitoring to see who is querying what and who's accessing data analytics. Also, we are a long-time partner of Databricks. We have many joint customers with them. Together, we help secure the data estates of some of the largest companies in the world. And not only is Databricks a very important partner, one of our largest partners in Immuta, they're also investors in our company as well.
All right, so I think it's good to level set, right? We're all probably aware of this. Data is scattered across many different silos in our organizations. We have data that lives in esoteric platforms that have been around for 10 plus years. We have data that lives in the lake. Things are all over the place, right? And the reality that most of our customers have come to is that they want a single point to access and manage their data. And Unity becomes this in many respects for our customers, certainly with some of the capabilities that we've launched around Lakehouse Federation. So this includes things like the ability to govern databases and warehouses. We talked about this, I think, relatively broadly at the keynotes. We have the ability to federate to databases like MySQL, Postgres, SQL Server, Snowflake, Azure SQL, Redshift, BigQuery, and there's more coming. And our goal is to allow you to be able to access data no matter where it lives without necessarily having to bring it into the lake. And if you want to bring it into the lake, that's great. There's an optional way to do that. But you don't have to. You can certainly query the data in place. We have some customers that say some pretty amazing things about Lakehouse Federation. Bayer, so Jel De Jong, who's a tech lead at Bayer, has opened up through Lakehouse Federation the ability for her data scientists and her business users to be able to access a whole bunch of data that both lives on-premise as well as in the cloud, all through one interface with a consistent governance pane. It's pretty exciting stuff. They're also in the process of sort of getting onto the Delta Lake standard, but Query Federation has helped them just start using Databricks and take advantage of what's in the platform and get things running quickly. And other customers, for example, Shell, Bryce Bartman, great guy at Shell, has also given us a wonderful quote that talks about Lakehouse Federation and its ability to also bring data sources into their target architecture. This ultimately makes it a lot easier for companies like Shell to be able to integrate the existing platforms that have been around for ages and years into what their modern data stack looks like. And Sega as well has given us a wonderful quote to talk about Lakehouse Federation and its ability to combine all the different transactional applications that they have across telemetry data from gaming systems and usage data from other internal systems that they have, as well as their actual sales and pipeline data. So they're able to kind of bring all that together without necessarily having to land it in a lake, without having to necessarily ETL it, and they can drive insights on it directly. So what is Lakehouse Fed? So Lakehouse Fed is actually available now. So Matei mentioned this on our keynote. This is generally available. It is data access, it is fine-grained access control, it is lineage, and it is auditing across all the sources that we talked about. So that includes, as I mentioned, Snowflake and Redshift and SQL Server, Postgres, et cetera, all these wonderful platforms. How does it work? Well, you register data from an external data source inside Unity Catalog. It's really straightforward. You create like a connection object, you use that connection object to register a catalog, and then you can start querying data. You get a single view, and you are able to securely explore all of this data without having to necessarily ingest it. You're able to govern it, so you can put ACLs on top of it. You can get audit. So for example, if I query a table, I'll see it show up in the Databricks Unity catalog audit log and system tables. I also have the ability to get all of the wonderful access control features that are powered through Unity catalog or coming from a partner via Immuta. On top of those data sources. And then more importantly, I have the ability to productionize and turn that into something that my customers can use at scale. And that's actually powered by a feature we have called materialized views, which is a fancy way of saying, I have this table, it lives in a SQL warehouse somewhere. I want to click a button and make it a table in a lake. And that's what a materialized view effectively is, right? And it can kind of refresh automatically or schedule or based on upstream changes to that table. From an overview and a roadmap perspective, we have this, and I talked about this briefly, right? This ability to create a connection. All a connection is it's an abstraction to a database, right? So all the things that you normally need to connect to a database, for example, a host, a port, a username, a password, they're all part of the connection object, right? Which makes sense. Once you've created this connection, you can now use it to set up catalogs. So you then create a catalog using that particular connection, and you tie it to a particular place in the Unity catalog hierarchy. In this case, that's typically aligned to a particular catalog within Unity. So that foreign catalog that exists in SQL Server or that exists in Snowflake or Redshift, you're able to make it show up as a catalog inside Unity. What we also do is we also try to leverage the downstream system as much as possible from a performance perspective, because we don't want to necessarily be in a situation where a query has to go and fetch all of the records that are in a source system and then bring them back and then filter them and perform predicates on them. So we actually push the predicates down to the downstream system. So what the Databricks Query Optimizer, which is part of Lakehouse Federation, does is it'll figure out what predicates are inside your query, and it'll go in and it'll actually run that predicate on the downstream system so that when the data is actually sent over the wire, it's much smaller than if you were to, for example, get the entirety of that table and then bring it back. This is similar to like what we do in terms of predicate filtering or partition filtering and pruning in Spark, but obviously through RDBMS, SQL semantics instead. Also, we talked a little bit. I touched on this briefly. Materialized views. The key things to kind of take away from this: consistency, latency, and concurrency for data that's outside of your lakehouse. The ability to accelerate cross-join. So I've got data that lives in different systems. I've got complicated transformations. I can put all of that into a materialized view, and that can be materialized as a table in my lake. This also, again, offloads access to underlying databases. So if I have a table that is like queried all the time, right? And I don't want to actually make that an operational burden for the person that owns that database or the team that owns that database. Instead, what I'll do is I would expose it as a materialized view. So some of these things actually make operationalizing, giving access in a virtualized pattern to the depths of your enterprise a lot more scalable. All right, so what about accessing data in UC outside of Databricks? Sorry, so we talked about this earlier. Matei had his wonderful red button moment on stage. I'm hoping some of you guys caught that, where he open sourced Unity Catalog. So we have open source Unity Catalog, and there's a few things that are a part of that, right? One is we have our open APIs, as well as the Iceberg REST Catalog API. So what we actually sell as a commercial product, you can now interact with, through a variety of different external platforms. We've listed out some of the compute engines and data platforms that are now able to connect to Unity Catalog, get the best of our catalog product, have some of that object level and hopefully soon fine-grained governance that some of our customers are looking for. And then also be able to operate across a variety of different data and AI assets. So it's not just tables, right? It's also objects like volumes and machine learning models and AI functions and things like that as well. So it's pretty exciting stuff. But what about accessing data outside of UC, outside of Databricks? So if I'm going to come into a SQL server directly, if I'm going to come into a Redshift database directly, if Databricks is not in my query path, how am I going to provide governance on those sources?
Thanks, Zeashan, and thanks for the mic. Would have been weird if I had to talk into Zeashan's shirt. All right, so yeah, so like Zeashan said, first of all, we're at Data and AI Summit, so everybody here only queries anything through Databricks, right? No, we serve like large, complex enterprises, some of which you all might work at, and there's definitely like, Databricks is not in every query path, and so we obviously have solutions like Federation to when Databricks can be in the query path, but when it's not. Immuta offers policy orchestration, and I'm going to put that in context here. So, like, basically, there's 3 ways to secure multi-compute. Actually, there's kind of 4 now because of the open source Unity, and it's supporting Iceberg REST API, Iceberg catalog spec, which is awesome. We're very, very excited about that, and we're also very excited about Ollie's Delta Berg or Ice Lake Vision, kind of converging the 2 standards. But the 3 ways besides for the new open source Metastore catalogs is data federation, so Lakehouse Federation, which Zeashan talked about a lot. And like I said, it's excellent for workloads that can query everything via the federation engine. In this case, Databricks would be Lakehouse Fed. Another way to secure multi-compute is a proxy. And it's exactly what it sounds. You put a proxy in front of all data access. We actually did that for first 5 years of our product, and I do not recommend it. There's a few reasons for that. One, it requires everything to be repointed. So if you are protecting even Databricks, for instance, then you put a non-reverse proxy. Let's say you put a Postgres foreign data wrapper in front of those tables, and you're not using Databricks to protect Databricks. Users aren't querying Databricks, so performance is not good, and also you have to if you have BI dashboards pointing to the actual table on the actual platform, you got to switch all that. You have to change SQL dialects unless it is true reverse proxy. It's a single point of failure. Don't do a proxy. It's my recommendation. And then the third, which is really where Immuta shines, is called policy orchestration. Now, what policy orchestration is it is using the native controls of the underlying platform, and there's a lot of benefits to that. Number one, you don't there's no change to how the data is accessed. So if let's say that you have a Snowflake, Databricks, and Redshift, and people are hitting those 3, actually querying those 3, you want to protect all 3 of those. For the Databricks workloads that you hit before you would start using a policy orchestration engine, you literally write the exact same queries the exact same way. There's no lock-in, and also this is maybe the biggest benefit is if you unify, if the orchestration is based off of a policy engine that allows you to grant access or to build authorization rules based off of semantics as opposed to physical. So something like tags or ABAC, attribute-based access control, then it allows you to write one policy or one set of authorization rules and have that enforced everywhere, because you're not saying that Zach can query this table in Databricks. You're saying, all users with a certain attribute can query all tables with a certain tag. And that can obviously work cross-platform, and that can be one policy and one rule. Whoops. All right.
There you go.
Yeah. Okay, so broadly, what do you need if you have this situation where, it's Snowflake, BigQuery, Redshift, Databricks. You need a single point to authorize all of your data, and regardless of where you query it. We have the Lakehouse Federation is an awesome feature, but where it's not an option to just like have everything route through Databricks, then you still need a single point like to write once, enforce everywhere, and authorize all your data using like common semantic rules. You also need fully audited access to all data, and that audit log needs to be consistent. Kind of like how you would do this, or like rolling your own. Every like Databricks has audit tables. All the other platforms have different audit tables. There's not like some open audit standard. Maybe there should be, but they all have like a different table schema. So what people would do without a tool like this is, or what you'd do is you'd push it all into SIM or something like that, or like CloudWatch, and then you'd have to like essentially do ETL to like harmonize it if you want to have like a common model for understanding all data access throughout your entire data ecosystem. And yeah, you also want to obviously write an access policy once and have it applied consistently everywhere. And if you couldn't catch where I was going there, this is what Immuta does. So I just wanted to take some time because we're all engineers here, so like I think there's probably like a desire to understand like how policy orchestration works under the hood. And so this is an example using like Databricks and Unity catalog. And so what'll happen is so this is showing like users writing a query, and then like up there, like a data steward is writing a policy in Immuta's attribute-based policy engine. And then as a user creates or edits an attribute-based access control policy, or as like user metadata changes, or as data metadata changes, user metadata can change from like coming in from Skim, or like we have APIs to update user attributes. And then data metadata can change from like table schema evolution. We are monitoring the like tables in the like various meta stores or equivalents of the data platforms that we protect data in. Databricks has discovery tags, for instance, and we can actually pull those in. So if you apply a tag on a column or a table in Databricks and you enable tag extraction, which is a feature that we offer in many of our data platform integrations, in addition to monitoring for like things like new tables or for table schema evolution of existing tables, we will also monitor for like tag changes, and then we will pull those tags into our policy engine, and then you can base a like authorization policy off of the tags that were that were applied in the platform. But yeah, so basically as a policy changes, or as user metadata changes, or as data metadata changes, Immuta will translate that ABAC policy into, in the case of Unity catalog, into the specific access policy. And so it supports both table, row, and column level controls. So if it's like a table level access policy, then we will, like, our policy engine will crunch all those rules, and it'll figure out like basically on which securables and to which principals do we need to grant select privileges or revoke them. What do we need to like grant modify to or revoke modify to? And then as far as like a row level or column level security, we would do much of the same thing, but instead we would like create, modify, and apply row filters and column masks on like securables in Unity catalog. And then Immuta does the same thing for all data platforms used as well, and also like we do it directly in S3, like directly at the prefix level. In the future, we'll do it for like ADLS Gen 2 or like OneLake, as well as for Google Cloud Storage as well. So this is like the single, I missed one very key point, which is like, so when you, coming back, like a user writes the same query that they would write, without Immuta in the picture, but then, so yeah, they don't change their query, and through this policy orchestration, working together with Unity Catalog, we're able to like orchestrate a policy that ends up being enforced like transparently to the end user with like very minimal performance degradation. I mean, it's like adding more stuff onto the query plan, so it's not going to be the exact same milliseconds, but yeah, it's like you're basically adding like compulsory where clause, or like you're just adding some more SQL, so it'll be a little bit. It'll run a little bit longer. But then also, what like Unity Catalog will do is it will write that audit log, and then we will sync that audit log back into our system. And so we abstract over all the differences of those various like audit log table schemas across all of the various platforms for you, and we like hydrate that with policy information that only our product knows about, and then we give it back to you in like a common audit model. So yeah, that was showing like, so this is like the single platform. This is a whole picture if you use this on one platform, which a lot of customers do, just because like, if you think about, we have customers with hundreds of thousands of tables and hundreds of thousands of employees, and the permutations can get really fine grained. So like, it can end up being a lot of row filters and a lot of column masks, and they can end up being really complex. And so people use us. I talked earlier, write once, enforce everywhere. Definitely, that's a very compelling value proposition. People also like use us to like write once, enforce in one place sometimes if the authorization rules are like super, super complex, or if they want to provide like a UI to more of like a data steward or a non-technical, somebody who's not a data engineer, to be able to implement the policies. But yeah, so this is like the full picture in a single platform. But then let's say you add another platform. Let's say you add Snowflake. It'll work the exact same way. Usually will send a query, data steward still like updates policy in Immuta, and then Immuta will like figure out in Snowflake like who to grant and who to revoke select from on like which roles. And we will also like create and modify row access and column masking policies, just like we create, modify, and apply row filters and column masks in Databricks. And then, yeah, I like tease the S3 thing, but I want to talk about that as well because, like, by far, I mean, I talked about like 3 ways of basically doing like multi-compute security. And I was really hard on the proxy because it's bad and you shouldn't use proxy. But so like a huge, I'd say like a first principle of our product is we call it native, right? So like no proxy and like nothing in the middle. Use like the native controls of the existing data platform. Now, up until recently, we weren't really able to do that in storage. But because of the new like AWS feature that the S3 team released, I mean, you could do this with like credential vending as well, which this actually basically is credential vending, but S3 access grants is it's like a second security model on top of like IAM bucket policies, or just IAM policies, and it is basically like it's a separate control plane and a data plane. So it's actually very similar to like table level access control, like granting and revoking select access. You like grant and revoke like read access or read write access to like various AWS principles. But basically, like this new feature that we worked very closely with AWS and another customer on, a big customer, both of ours on. Yeah, it allows us to actually do like for the first time a native storage integration. Again, native meaning like there's no proxy in front. And so basically the way this works is same flow with the data steward. Data steward sets, changes rules, user attributes change, data attributes change, like of the specific S3 prefix. And we like translate that prefix into like prefix level access grant. And then the way that the user can request, what the user does, they don't directly say like, give me this file. They first have to request for data access, and if the user is authorized, then we'll return like those three things, like the session token, the access key, and the secret. Or actually, S3 access grants will return it. We're just like pushing into the control plane. And then you can use those like temporary time-bound credentials and have like zero standing permissions, because these are like the session expires at like a user-specified TTL. So like there's also some really good like security features baked in here. And then, but with that temporary time-bound credential, which grants the authority to like either read or write into like the specific requested prefix, then the user will be able to like request access, and then that'll come then that works just like any sort of like if you have an STS, like if you call the STS API and get back credentials, that's like what you're holding with those three things, and so it works the same way as it would if it didn't go through S3 access grants. But and so yeah, and we're able to like enforce policies and be like totally out of the like request like totally out of the data access path there. And then yeah, similarly, that's all written into like CloudWatch CloudTrail, and can be hydrated into Immuta. All right. Well, thanks. That's all I have. Thank you, everybody.